Hi everyone, let us discuss this example. In this example, we have to find the value of surface integral of a scalar field f. This is given f, right, over a given surface. So surface is also mentioned here. So let me write the definition of surface integral of a scalar field first. Okay, so we know that, let me write. We know that double integration of f over surface S is equal to double integration over d, right, f of phi of uv. Phi is what? Phi is a parameterization of a surface S, right, and phi is defined on domain D. So this integration we solve on domain D, right. Norm phi u cross phi v du dv, right. So this is a definition of surface integral of a scalar field. So for that we need to have one function f. So in this problem they are already given to us. We want the parameterization of surface S, that thing we have to find here. Okay, so let us start to solve this problem. So what will I do? I will write the given function first. So we have what is the function we have? F of xyz is equal to, they have mentioned it is x square plus y square, right. Let us talk about the surface now. What have they mentioned? S is the surface. So let me simply mention S. Surface we have, what is its equation? X square plus y square is equal to 2 minus z. So as you can see here, the power of z is 1, power of x and y is 2 and power of z is 1. That means it represents a paraboloid. Getting it? Represents a paraboloid and it rotates around z axis since power of z is 1. So we have this type of paraboloid. Okay, this type of paraboloid we have here. Z has a minus sign. That means that paraboloid, okay, which is around this z axis, it is in direction of negative z axis. That means that paraboloid opens in the direction of negative z axis. So we will have a paraboloid like this. Getting? So we are interested to draw that paraboloid there. So what will I do? Let us find that paraboloid cuts z axis at which point. So for that what will I do? I will put x and y 0. If I put x and y 0 and if you solve, obviously you can easily guess the value of z will be 2. What I am doing, I am putting x and y 0. If I put x and y 0, value of z will be 2. That means this paraboloid, that paraboloid cuts z axis at point 0, 0, 2. Okay. As well as we are interested to find the curve of intersection where this paraboloid cuts to this xy plane. What is the equation of xy plane? Z is equal to 0. To find the curve of intersection, I am going to put z is equal to 0 here. Tell me what will I get if I put z is equal to 0? We will have x square plus y square is equal to 2. Let me write here. X square plus y square is equal to 2. So we know that it is equation of circle in xy plane, okay, with center 0, 0 radius. What is its radius? Root 2, since we have a 2 here, right? So we have a circle, we get a circle here with center 0, 0 radius root 2 in xy plane. Okay, let me draw it properly. This type of circle we have, right? And our paraboloid in the direction of negative z axis. So our paraboloid will be like this. Okay, it is the direction of negative z axis around z axis and it cuts xy plane in this circle. X square plus y square is equal to 2 and it cuts z axis at point 0, 0, 2. So in this way we got the paraboloid. So now we have to find its parameterization. You remember in previous videos on the playlist of that double and triple integration, we have already seen when we have paraboloid, when we have cone or when we have cylinder, we go for cylindrical coordinate system. Getting what did I say? When we have paraboloid, when we have cylinder or when we have cone, we go for a cylindrical coordinate system. I will do the same. We have a paraboloid here. So let us go for the cylindrical coordinate system. So for that I am going to put, see what have they mentioned above the xy planes. I should mention here above xy plane. Okay, that sentence I should add here. Yes, above the xy plane. So this surface we have here. Okay, so we put, what we should put? Do you remember how to convert a problem into that cylindrical coordinate system? For that we put x is equal to r cos theta and y is equal to r sin theta and z is equal to z itself, right? So in this way we convert a problem into cylindrical coordinate system. But the problem is that we have to find parameterization. That means we have to reduce the variables. If again you will have r theta and z, that means 3 variables. Variables are not reduced here. So for that we have to convert, okay, all the problem in 2 variables only, r and theta. So what we have to do with this z? We have the equation of this paraboloid. What is it? X square plus y square is equal to 2 minus z. That means, will you tell me what will be the value of z using this equation? Z is equal to, using this equation I am writing, z is equal to 2 minus x square minus y square using this equation. So you know that x is r cos theta and y is r sin theta. So let me put here, so 2 minus r square cos square theta minus r square sin square theta. Okay. So we have some space, let us use, okay. Just a minute. Yes, we got it. See, can we take r square common? Obviously, if you take r square common, we will have z is equal to 2 minus r square. In bracket, if you take r square common in bracket, you will have cos square plus sin square, which is 1. So that 1 into r square. So this is a z, right? So x is r cos theta, y is r sin theta, and z is equal to 2 minus r square. So in this way, we convert a 3 variables x, y, z in terms of r and theta only. So we can declare our parameterization. Then parameterization of S is phi of r theta. I will mention. What is our x? R cos theta. What is our y? R sin theta. And what is our z? 2 minus r square. So now we have 2 variables r and theta, so we should find its limits. R means what? Radius. See, in xy plane you can easily see we have this circle whose center is 0, 0 and radius is what? Root 2. So that's why r should vary from 0 to root 2, right? What about theta? So we have to cover a complete region, getting? That means we should rotate it by 360 degrees. So theta should vary from 0 to 2 pi. So in this way we got the parameterization phi. Okay, so after that what we have to find? We have to find derivative of phi with respect to r, with respect to theta, cross product, norm, f of phi of r theta. After getting it all, we will put all these equations here, and by solving the integration we will have the final answer. See, there is no more space to write. Make a screenshot of it first, then I will go further. Okay, so let us find these things one by one. Okay, so we have phi. So let me find here. Okay, so then derivative of phi with respect to r we want. Okay, so I am taking derivative with respect to r. So derivative of first component with respect to r is cos theta. Since derivative of r is 1, cos theta is constant. What about this? Sin theta is constant, derivative of r is 1. What about the last component? 2 is constant, derivative will be 0. R square, its derivative is 2r, so minus sign is there, minus 2r. Let us find derivative of phi with respect to theta. This time r is constant. Derivative of cos theta is minus sin theta, r is constant again. Derivative of sin theta is cos theta, right? And see, there is no any theta, so the entire term is constant, derivative will be 0. Yes, so now we are interested to find phi r cross phi theta. We want the cross product. So you know we solve the determinant to find the value of cross product. So the first row is obviously I, j, k. This will be the second row, cos theta, sin theta minus 2r. This will be the last row, minus r sin theta, r cos theta and 0. Okay. So what will I do? I will solve the determinant. I, product of these two, which is 0, minus product of these two, so minus minus plus 2r square cos theta. For the middle term, we always write a minus sign there, minus j. Product of these two, 0, minus product of these two, so minus minus plus, but again it has a minus sign, so 2r square sin theta, right? Let me write here, plus k, okay. So k, product of these two are cos square theta, obviously there is a minus sign, and product of these two, minus minus plus, r sin square theta. Okay, so this is equal to, so the first component is 2r square cos theta, right, comma, c minus minus plus 2r square sin theta, okay, comma. See, if you take r common, we will have cos square plus sin square, which is 1. So we will have simply r. This is cross product, so let us find the norm. Phi r cross phi theta. Norm means simply square root of. We add the square of each component. So the square of first component is 4r raised to 4 cos square theta plus its square 4r raised to 4 sin square theta plus its square is r square. So now what will I do from first two terms? I am going to take 4r raised to 4 common, okay. So let me remove this parameterization, so we will have some more space to write. See, I kept it there because we have to find f of phi of r theta also, na? So yes, let us continue. So this is equal to square root of, what did I say? I am taking that 4r raised to 4 common, 4r raised to 4 from first two terms only. So cos square theta plus sin square theta 1 again, right? So only 4r square raised to 4 will be there plus r square. Will you tell me what can we take common? We can take r square common. But see, when r square will come outside the square root, it will be r only. So r will come outside square root of 4 r square plus 1. So this is value of norm. So let us go for f of phi of r theta. Now f of phi of r theta. So f of, what is phi of r theta? This one, r cos theta plus comma r sin theta 2 minus r square. So now we have to apply this definition of f. Definition of f says square of first component plus square of second component. We don't need to consider the third component. So this is equal to square of first component r square cos square theta plus r square sin square theta. That's it. Again we can take r square common. If you take r square common, we will have in bracket cos square theta plus sin square theta, which is 1. So that's why r square. So in this way we got f of phi of r theta is r square, and norm, value of norm is r square root of 4 r square plus 1, right? So let us put all those values in the definition. Okay, we are going to do that. Just make a screenshot of it first. So let us find value of surface integral now. Okay, so the definition I wrote here. So we know that the limits of r are 0 to root 2. I have written the same, and theta varies from 0 to 2 pi. So in the definition we are going to put values 0 to 2 pi, 0 to root 2. F of phi of r theta, we got its value is r square, and value of norm is that r root 4r square plus 1. Here we have a square, okay. Yes, and after that we have dr d theta. So we have to solve this integration. First we will integrate with respect to r, and then we will integrate with respect to theta. But see, this integration is looking complicated. So what will I do? I am going to substitute. I am going to put something to make it more simple. See, what will I do? What shall I put? Any suggestions you have? What will I do? I am going to put whatever the inside the square root, that thing I will consider that as a t. So 4r square plus 1 is equal to t. So when we put anything, after that we have to take derivative compulsory, and we have to find its new limit. So I am going to do the same. So what will be its derivative? Derivative of 4r square is 8r, right? 4 as a constant, derivative of r square is 2r. 1. Derivative of 1 is 0, since it is constant. We write dr here, derivative of t is 1, I will write dt. So 8r dr is equal to dt, that means r dr is equal to dt by 8. The important thing we got, right? Yes, that means this r dr, you can see here r and dr, both of them can be easily replaced by dt by 8. So let us find new limits now. For r is equal to, what are the given limits? 0, and r is equal to what? Root 2, okay. So let us find the values of t. So what I am going to do, simply I am going to put r is equal to 0 here. If I put 0 here, 0 square 0, 4 into 0, 0. So only 1 is left. So t is equal to 1 if you put r is equal to 0 here. If you put r is equal to root 2, let us see what will be the value. 4. Root 2 square is 2 plus 1, that means 8 plus 1, 9. So the value of t is 9. So t varies from 1 to 9. Okay. So let me write here. Okay, I am going to write here. So therefore, double integration f over s is equal to 0 to 2 pi, Okay, this new limits we have to write for this inner integral. T varies from 1 to 9, okay, 1 to 9, r square. Okay, we need to find a value of r square. So for that, what will I do? Here we have some space, so I'm going to find the value of r square. So 4r square is equal to t minus 1. Agree? Yes, so r square is equal to what? T minus 1 by 4. So this is value of r square. So at a place of r square, we can put this value. So this is t minus 1 by 4. Okay. Root, we have a root here. Root 4r square plus 1, that means t. And r and dr, we can easily replace by dt by 8. dt by 8, agree? Okay, and d theta is still there, d theta. So first what will I do? Whatever the constants we have, I will take them outside. So as you can see here, 4 into 8, 32, it's a constant. So let me take it outside, 32, 0 to 2 pi. Okay, so it is looking complicated. So let me solve it. So root means what? T raised to 1 by 2. So this, okay, I will write properly so you can easily understand. T raised to 1 by 2 dt and d theta. So see, we have to solve this integration. So for that, what will I do? I will multiply. I will solve the bracket. T into t raised to 1 by 2, that means t raised to 3 by 2. When you take a product, we need to add powers. 1 plus 1 by 2, 3 by 2, minus t raised to 1 by 2 and dt and d theta. So I'm going to solve this integration. Okay, just make a screenshot of it first, then I will go further. Okay, so therefore double integration of f over s is equal to 1 upon 32, right? 0 to 2 pi. Okay, I'm going to integrate t raised to 3 by 2. Its integration is t raised to 5 by 2 by 5 by 2. Integration of t raised to 1 by 2. T raised to 3 by 2 by 3 by 2 with limits 1 to 9 dt. Sorry, d theta we have. Already we have integrated with respect to t. Okay, 1 by 32, 0 to 2 pi. I am putting the upper limit first, 9. So 9 raised to 5 by 2 divided by 5 by 2 minus, here also I am going to put 9 raised to 3 by 2 divided by 3 by 2 minus, I am going to put 1. If you put 1 raised to anything 1 by 5 by 2 minus, getting? But see, already there is a minus sign, and when we put a lower limit, again we write a minus sign. So minus minus plus 1 upon 32 d theta. Okay, so yes. So now let us find the values separately. Let me show here. 9 raised to 5 by 2 means basically 9 raised to 1 by 2 raised to 5. 9 raised to 1 by 2 means root 9, which is 3. So 3 raised to 5, that means 3 into 3 into 3 into 3 into 3. So 3 raised to 4, 81 we know, into 3. So 3, 243. Okay, so its value is 243. Let me write 1 by 32, 0 to 2 pi. This is 243 divided by 5 by 2. 9 raised to 3 by 2, same technique we have to apply. 9 raised to 3 by 2, that means 9 raised to 1 by 2 raised to 3. You know that 9 raised to 1 by 2, root 9, which is 3. So 3 cube, which is 27. So it is 27, okay, by 3 by 2. 2 is in denominator, of denominator will go through numerator, same thing will happen here, okay. D theta, so this is equal to 1 by 32, 0 to 2 pi. Let me shift this 2 at a numerator. So 2 into this one, 684 by 5. Here also I will shift to the numerator. So 27 into 2, 54 by 3 minus 2 by 5 plus 2 by 3 d theta. So 1 by 32. So it's all constant. So we can take easily outside the integration. So both of them have the denominator 5. So you can subtract numerators. So 484, right? 484 by 5 minus, here both of them have the denominator 3. So you can add numerator. So it will be minus 52 by 3. So here it's a constant. I have taken it outside. So in an integration we have d theta only. Its integration of d theta is theta with limits 0 to 2 pi. So we have to put upper limit, lower limit. So let me write here 1 upon 32. See, what will I do to make it more simple? I will divide. See, 2 I will get cancelled. So if you divide it by 2, you will have 16. Here if you divide it by 2, so 242 by 5. Here also I will do the same. So it is, it will be 26 by 3. And if you put lower limit, upper limit, it will be 2 pi minus 0, 2 pi. Okay, so I am going to solve it further. Just make a screenshot of it first, then I will go further. So let us utilize this space now. Okay. See, as you can see here, the numerators are again divisible by 2. So I can easily cancel 2. Here also we have 2. So 2 also will get cancelled. So simply I will divide denominator by 4. And here I will cancel 2 and that 2. So 4. So this is equal to 1 by 4 only. I am dividing by 2. So it is 121 by 5. So calculation will be more simple. For that I am doing. Using calculation you can easily get it. So if you divide by 2, it will be 13 by 3. And here also 2 we have cancelled. So it is pi. Let us cross multiply. So this is equal to 1 by 4. And see 1 by 4, right? And yes. 363 minus 65 divided by 15 pi. Okay, so we have to subtract now. So if you subtract, it will be 8, and here yes 9, 2 and 15 pi. Okay, see again both of them are divisible by 2, so I will cancel out 2. So 2 into 1 4 9 pi by 15. So it is 149 pi by 30, right? So this is the final answer we have got. Make a screenshot of it, then we will stop. Thank you.